Okay, welcome back to Physical Science Online Edition. Um, for our electricity notes, my goal this time, being realistic, I'm aiming for 2 videos. See what happens. So this is just a really cool quote I like to share with students at this time of year. Electricity, end of the year projects. We're getting into rockets and stuff like that. Really seems to be a good place to put this. Is that all you need to be an inventor? An imagination and a pile of junk. There's actually schools that do that they provide just a pile of junk and let you create stuff out of it and have some fun and do stuff like that. We don't have time to do that this year, but just kind of a cool thing to think about off to the side, apart from all the other stuff going on. Then let's get to the real stuff. So Ohm's Law, we've learned about Ohm's Law in class already. We've done a little bit of math with it. Just want to make sure it's in your notes. This is a different version of it. I like V equals I times R a little bit better. Technically, when he first was doing his research, he was more concerned with the current. So his technical law is written I equals V divided by R. Doesn't matter how you rearrange it. Just remember that I is the weird one, stands for current measured in amps. V is voltage measured in volts. And R is resistance measured in ohms in honor of George Simon Ohm from the late 1700s. I mentioned this in class when we did our straw lab. There's one really easy way to think about electrical currents in general. And that's to think about them as a river or as a straw. Really great analogy. It works almost perfectly, especially for broad terms, maybe not specific, but for very broad terms. So voltage is the force that pushes the current through the circuit. In this picture, it'd be the gravity. Gravity is the force that makes rivers go downhill, go down. If you didn't know, all rivers and streams are actually running downhill, and they're propelled by gravity. They're going from potential energy into kinetic energy the whole way downhill until they reach a body of water. And that's what voltage is. It's how much energy, how much potential energy there is, how much power there is, how much push there is there. Just provided in either your wall outlet or in a battery instead of by gravity and the steepness of the hill. Resistance. Resistance is friction that impedes the flow of electrical current. Okay. You can think of resistance as like rocks in the river. So you add a light bulb to your current, all of a sudden it's like adding a big boulder. It's getting in the way. Or if you add more river, if you make it longer, that'd be like adding more resistance, more friction. So that's what resistance would be like. And once again, our river analogy works very, very well. Current. Current is the amount of stuff that's flowing through. So it's kind of like the amount of water through a river. That river in that picture would have a very high current. And in our electricity, we're just talking about electrons. Electrons are a thing that moves around and actually provides that energy is the movement of electrons through the circuit. So pretty cool, and especially if you like to be out in rivers and know a lot about rivers, it's a really good analogy. You can also think of your straw lab if you're more familiar with that. So now just showing some circuits. So we're basically just asking you to know a little bit about circuits, a little bit of common sense behind these things that we use every day. We use circuits, batteries, electricity every single day. Our society relies on it a lot. Your house, your phone relies on it a lot. Would this work? Hopefully you answered no. How about this one? Would this one work? Hopefully you answered no. And would this one work? Yes. Hopefully you answered yes. So this one doesn't work because there's nothing connected. It's not a completed circuit. This one doesn't work because it's connected to the same end. There's no difference between positive and negative ends of the battery. And this one does work because it would flow through the circuit from negative to positive. It would flow along and provide that energy. You need a closed circuit in order to complete that loop, that flow of electrons. Okay. Try to get this done in the next video because that's the end of this one. Thank you.